She was like this.
I'm now recording, so.
Oh, good.
I was going to say somebody would. All right, so we're doing Hess's law. I don't really know who Hess is. I'm sure he was a scientist that had more time on his hands than you and I do. So anyway, but I do like Hess's law. To me, it's like a puzzle. So we're still doing the same thing. We're finding the delta H of reaction, but this one you'll see is not as number heavy. So so enthalpy is not dependent upon the reaction pathway. So we usually write reactions that they're just one step, but in reality, it's usually a series of little steps that get you there. And it doesn't matter how those steps are ordered, as long as you get to the same place. So for instance, if my princess here was leaving where her dad works at, and I was leaving my apartment, then when we both came to Bay City High School, we may get there in different ways, but in the end, we would both get to Bay City High School.
Look at what y'all did.
I was really having to process that up here in my mind to come up with something quickly. And that's all I can teach now today because I used all my energy up. All right, so that's what we're going to be looking at. And we're going to see if we can't rearrange the the equations that we know and the delta H's that we know along with them to get a delta H for the reaction that we're really interested in. Sounds a whole lot worse than it is, I promise y'all. If you'll open your mind, why won't this let me move? It can actually be a little bit fun. All right, so let's just start here with this little one. All right, so you'll have what's called your summation reaction. That's your overall reaction. That is the reaction that you're trying to figure out your delta H. And then you'll have these other reactions where you know a delta H that have the same products and the same reactants in them, along with some other things that you probably don't need. So I want to take these two and I want to see how I can manipulate them to give me my summary reaction. If the equations, so they're talking about these equations I'm working with, if they have to be reversed, then you have to also reverse the sign of their delta H. So if I'm going to reverse one of those, I would have to reverse this. And if it was positive, it would become negative, or negative, it would become positive. If equations have to be multiplied to get a correct coefficient, then you also had to multiply that coefficient by the delta H, or divide if that's what you need to do. So basically, whatever you do to these equations, you also have to do to their delta H. So we'll start off with this simple one. All right, so if I look at this one, I have carbon as graphite going to carbon as diamond. Not even a phase change, kind of just a structure change. So if I start looking, you just got to have one thing that you want to start with. So I'm going to look at my C graphite. I need it to be a reactant, which it is. And I only need one. I don't have another coefficient in front of it, so that is also correct. So right now it looks like that equation is going to be helpful as it is. Here I need C diamond, but I need it to be a product. And right now it's a reactant, so I need to flip that equation, flip it over, so I can get that on my product side. So it would become CO2 yields C, I'm just going to put CD for diamond, plus oxygen. And instead of negative 396, it becomes a positive 396. I like to scratch that out so I won't accidentally get confused. All right, so at this point, I'm going to kind of see what I have. I have my C graphite. Yep, that looks good. I have my C diamond. Yep, that looks good. I got these other things that I don't need. So now I need them to cancel out. And just like when we did net ionic, if one is on the reactant side and one is on the product side, I can cancel them out. So this CO2 is on the reactant side, so we can cancel out with that CO2 on the product side. This oxygen is on the reactant side. This oxygen's on the product side, so I can cancel them out. So now I've gotten rid of everything I don't need, and I just have what I do need. So I have C, graphite, solid, yield C, diamond, solid. And now to get my delta H of reaction, these are my numbers. I add them together. Negative 394 plus, it ends up being a positive 2. And the units are the same as they are there, kilojoules per mole. Neither one of those numbers had any places behind the decimal. So when I add them, they would not be any places behind the decimal. Is that a very spontaneous reaction?
Yes.
It is. Anybody disagree? Well, I mean, I feel like if it's really spontaneous, we'd all have a lot more diamonds laying around, which that's not a thing. It's precious. No, I mean spontaneous. What does it have to be spontaneous? What kind of reaction is it usually to be spontaneous? Endothermic or exothermic? Exothermic. Is that an exothermic reaction? Oh, that's an endothermic reaction. It doesn't require a lot of energy. That's a small amount, but it's still not exothermic. So that's why you don't see a lot of diamond laying around. You got to find some energy for that to happen. And that energy usually happens with like heat or pressure, because that's going to be where you usually find your diamond.
How many diamonds do you think are closer to the core of the earth?
I thought you were going to ask me something like how many diamonds you have, and I was going to be like, I had one. I gave it to my son to give to his fiance when they got married. I do like her, and now she's having a baby. She's pregnant. Did I tell you that? Did I find out that my daughter-in-law was pregnant on Mother's Day?
On Mother's Day?
Your sister-in-law that works with my daughter out of the dome.
The PT, yes.
Yeah. Thank you. Yeah. So anyway, they had been having a hard time. So because when she was young, she had like in her high school years, she went through cancer like twice. So anyway, but they found out there. Yeah. So I'm excited. I'm in charge of the reveal party. Party time. Last night I went and took care of my grandson, the one that lives in Bay City. Oh, I was so tired. I was already tired, and he is so active. Oh my gosh, I was exhausted. I'm gonna have to, yeah. He needs to start walking. That'd be easier when they start walking.
It's just hard for me to imagine like how much my mom had to go.
Oh no, I can't imagine.
But then they get into so much more stuff when they start walking.
Well, I know that's what my daughter says. But for me, I don't.
As long as they can sit up and hold their own bottle, then that's wonderful.
He can't do that. He is a genius, but you know. All right, let's look at a couple that get a little bit harder. So here's my next one. Once again, that's still my summation reaction. And so things like oxygen and nitrogen, I kind of leave those, like hydrogen. I grab like the things that are kind of like a little bit different. So to me, that would be my NO and my NO2. The other things that you would want to leave, see how oxygen is in 2 places? Leave that to the end and hope it works out. Because, if not, you're trying to get one oxygen settled in one equation and then the other one messes it up. So kind of like when we were balancing equations, if you had an element in more than one place. So I'm just going to grab it onto my NO. And what I notice about it is it's a reactant, but over here it's a product. I only need one NO. So that's correct, but I need it on the other side. So I'm going to flip it. 1/2 nitrogen plus 1/2 oxygen and make that a negative 90.29. And I'm going to, for now, say I'm through with that one. Yes, I don't understand. I'm sorry.
On the first example, you like crossed out the equation in the bottom.
Well, because on that one, that was the one I flipped the second equation. Here, I flipped the first equation.
So we don't have to put like what state is.
Not here, because this is kind of like just doing your work, and then you'll notice when I do my final one and give the answer, then I put the states back on them. All right, so my NO2 is a product, and here it's a product. So that one looks like it's going to be good. So once again, I'm going to take a minute, and I'm going to see what I have. So I need NO, and I have NO. And what else do I need? I need NO2, and I have NO2. So I got some things that I don't need. So let's see what I can get rid of. I have a half a nitrogen, and on these you can have coefficients that are not whole numbers. You won't have to balance any of these, but that is possible. I get rid of my nitrogen. Here, even though it's not written, I have one oxygen, and there I have a half oxygen. So I can get rid of that half, and this will go down to a half, which is actually the thing that I was lacking because I needed a half of oxygen, and now I have just my half of oxygen. So now I've got it all correct. So I'm going to put it back together and do my numbers. So I have NO as a gas plus my half of my oxygen as a gas gives me my NO2 gas. And then my delta H of reaction. So now these are my two numbers I got to deal with. So 33.2 plus a negative 90.29. And those, the 33.2 only has one place behind the decimal. So my answer should have only one place behind the decimal. Negative 57.1 kilojoules. Kind of messy. Per mole.
How do you know whether you're solving for the top equation or
You don't, there's not always this, the one that that's your summary. So that's what you're trying to make the other ones get to by adding them together.
This, you're gonna make this like these two, this make match this.
Yes, sir. Yeah. So the ones below are the ones that you're trying to use to match your summary equation. All right. So if I asked you, now you did all this work, and then my answer is write a thermochemical equation with your answer. What would I do with my information that I worked out? Where would it go? Is that exothermic or endothermic? Exo. So would it be a reactant or a product? A product. Yeah, it'd be a product. So I would put my 57.1 kilojoules. And would it be a plus sign or a minus sign? Plus. When you put those numbers in your equation, they're always plus. If you go back and look at our notes from Tuesday, and then it says if you take it out to use it in a calculation, you have to give it a negative sign. So that would be your thermochemical equation. If this would have been a positive number, then instead of being a product, it would have just been fit over here with your reactant still saying plus 57.1. Because that's a good question. I feel like you're probably going to see that next week. When is that for y'all? Next Thursday? Your test? Well, not. I'm sorry. You're right.
yeah, we end our now.
2 Thursday. All right.
Our year in chemistry.
It'll be good.
Literally the last day of school.
Do you know how many questions it's gonna be required?
I know. I haven't even gotten to that.
Second and seventh.
I haven't got to that.
Who's the?
All right, let's move on and look at one that gets a little bit harder. Okay, so it says calculate the delta H of reaction for this one. So this is my summary. The other way that you can see it, know it's your summary is I don't have a delta H of reaction value for it. That's what I'm trying to figure out. And this one I have to work with 3 things. All right, so my first thing that jumps out to me about my carbon is that it is a reactant, so I'm good here. And carbon is only in that first equation. It's not in the other 2 equations. If it was, I would not go to it first. But how many carbon do I need? 5. So I need to multiply this by 5. So it becomes 5C plus 5O2 gives me 5CO2. And then I also have to multiply my negative 393 times 5. Still stays negative. 1967.5. All right, and I'm going to scratch that out. And Deja, that just was a coincidence that happened in the first one, okay? But I'm going to skip my hydrogen because sometimes those can be a little hard. And then I'm going to go to, once again, this kind of odd, something that's odd. So if you'll notice, that one is on my third one. So right now I'm not going to do anything with my second equation. I'm going to come all the way down to my third one. I only need 1 mole of it. So that's correct, but it's on the wrong side. So I'm going to need to flip this one. Am I going to? Yes, I am going to need to. I got myself confused there for a while. 5CO2 plus 6H2O yields C5H12 plus 8O2. And it will go from a negative to a positive 3536.6. All right. So now I got my 2 things with carbon. So now I have to address my hydrogen, and it's not going to be bad because hydrogen's only in one equation. So I need 6 hydrogen, and it's on the right side here. So I need to multiply this equation by what? 6. 6. And notice that you need 6, like not 6 atoms, you need 6 moles of H2. So it comes 6H2 plus 3 oxygen gives me 6H2O. And then I need to do my negative 285.8. I need to multiply that by 6. All right. And I'm going to scratch this one out. And then, like I said, I like to, and when I actually do these, I probably have 2 different color pens going. I like to get and circle what I need. I need 5 carbon. I need 6 hydrogen, and I need 1 of this hydrocarbon. Whew. So that looks like I have a whole lot left over. So now I'm just crossing my fingers. It can all cancel out. And I'm going to start off, I have 5 CO2 on the reactant side, 5 on the product side, 6 water here, 6 water there. And then for my oxygen, I have a total of 8 on my product side, and 5 plus 3 will give me 8. So I get to get rid of all of those. And I got what I wanted. So I just rewrite, and I'm going to then deal with my numbers. Yes, exactly like that. Yes, ma'am. So there are my numbers. I'm going to add them all up, and they all have 1 place behind the decimal. So my answer should also be 1 place behind the decimal. I got negative 145.7. Does that sound familiar to anybody? Oops, forgot my 1. Kilojoules per mole. No, I'm not going to do that to y'all. I would have done that earlier in the year, but it's too late in the year now. All right, so that gives you a little bit of time to look at some practice. If you want to, if you're still struggling up, bring it up here and we'll work through a problem to begin with. Because really, once you kind of see, it's not so bad, but you got to grab on something to start with. And don't choose something that's available in 2 of the equations that you're having to use to get to your summation equation. Because that makes it a little hard.